For years, scientists have puzzled over a question. Why are nitrate levels going down in some groundwater aquifers, but rising in others? In southeast Minnesota's karst region, nitrate from agriculture is a persistent groundwater contaminant. Long-term monitoring reveals a mixed picture. Nitrate concentrations are declining in some locations, but rising in others. What's driving these different trends? New research suggests that part of the answer is written in the age of the water itself. Groundwater age, also called residence time, is how long it takes water to travel from the land surface into underground aquifers. While karst landscapes are known for rapid water movement, not all groundwater moves at the same speed. Groundwater follows many complex flow paths, mixing along the way, and arriving at springs, streams, and wells at different times. Estimating age across the system and at varying depths is key to understanding nitrate trends. To investigate, an interagency team of scientists analyzed nearly 20 years of nitrate and pesticide data from a network of springs and wells. They estimated groundwater age using a clever dating technique, tracking an herbicide that was widely used in the 1970s and 80s, but is no longer used today. By comparing historical usage with present-day concentrations in groundwater, along with other dating methods, land use records, and climate data, new patterns emerged. Here's what they found. Groundwater age ranged from 10 to 40 years in many springs and wells and increased with depth. In deeper aquifers, groundwater ages ranged from several decades to thousands of years. These differences are controlled by local geology, including low permeability rock layers called aquitards, which slow the downward flow of groundwater. When researchers compared groundwater age with nitrate trends, a clear pattern emerged. Younger groundwater, less than 20 years old, has higher and more variable nitrate levels with no clear trend, and in some cases, declining. Improved conservation practices may be helping, but dilution from excess precipitation likely plays a dominant role. Older and deeper groundwater, usually more than 30 years old, generally has lower nitrate levels, but concentrations are slowly climbing by 1 to 4% per year at certain locations. These increases reflect fertilizer and land use practices from decades ago, only now reaching deeper aquifers. Rising nitrate trends are especially common in springs and streams in the eastern study area where aquitards are less protective. These trends are expected to continue until a balance is reached between historical and current practices. Together, these findings show that groundwater responds on its own timeline, shaped by geology, water age, and land use history. This insight helps guide clean water goals and underscores why sustained conservation today is essential for groundwater protection into the future.